Hi everyone. In this video, we shall see the topic large sample test. Large sample. If the size of the sample is greater than 30, then the sample is said to be large sample. And here we have four important tests to test the significance of large samples. First one is to test significance for single mean. Next one is test of significance for difference of two means. Next one is test of significance for single proportion, and the last one is test of significance for difference of proportions. The critical values for some standard level of significance are given below. That is, nature of the test is given, that is two-tailed test, whose corresponding at 1% level the table value is 2.58, and at 2% level of significance the corresponding critical value is 2.33, and at 5% level of significance the corresponding critical value is 1.96, and at 10% level of significance the corresponding critical value is 1.645. Similarly, for the right tail test and left tail test, the level of significance corresponding critical values are given. Test of significance for single mean. The test statistics is given as z equal to x bar minus mu by sigma by root n, where x bar is the sample mean, mu is the population mean, sigma is the standard deviation of population, n is the sample size. Now here, if the standard deviation of population is not known, then we can use the formula z equal to x bar minus mu by s by root n. Now let us see a problem, that is, a sample of 100 students is taken from a large population. So sample size is given as 100, that is n value is 100. Now the mean height in the sample is 160 centimeter. So sample mean is given as x bar equal to 160. Next, the problem is, can it be reasonably regarded that in the population the mean height is 165 and standard deviation is 10, that is population mean as well as population standard deviation is given, that is mu and s value, where mu value is 165 and s value is 10 centimeter. So we have to find the confidence limit, and the level of significance is given at 1% level. So given values are written. First step is to set up the null hypothesis H naught, which is mu equal to 165. This is the statement we are going to check. Step 2, set up the alternative hypothesis H1 such that mu not equal to 165. Since mu not equal to 165, we use the two-tailed test critical values. Now step 3 is level of significance alpha is given as 1%, which is 0.01. So the corresponding critical value is z alpha equal to 2.58. Step 4, the test statistics is z equal to x bar minus mu by sigma by root n. Here we know that x bar value is 160, mu value is 165 and sigma value is 10, n value is 100. So by substituting those values, we have the test static z value is minus 5. So we have mod z value is 5. Now compare the calculated value with table value. Here the calculated value is greater than the table value. Hence H naught, that is the null hypothesis, is rejected, and hence the alternative hypothesis H1 is accepted. That means the conclusion is mu is not equal to 165. Now let us find the confidence interval. We know that the formula is x bar minus z alpha sigma by root n, comma x bar plus z alpha into sigma by root n. So in the place of x bar we are replacing 160. In the place of z alpha, since the level of significance is 1%, we have z alpha value is 2.58, sigma value is 10 and n value is 100. By substituting those values, we have the confidence interval is 157.42 comma 162.58, which is the required confidence interval. Thank you.